There's a lot of observations to be made about physical matter, and it gets kind of complicated to organize all this information. What scientists like to do is we like to classify things, categorize things. People do this in everyday life too. We categorize vehicles into different classes. There are 18-wheelers, and there are pickup trucks, and there are panel trucks, and there are SUVs and small SUVs, and full-size sedans, and compacts and subcompacts, right? And we've classified vehicles that way. You can also classify vehicles by their number of wheels, or by the color, or how many people they seat, or how many doors they have. And so you could have several different categories that a single vehicle might fit in. It might be a red car, it's got 4 wheels, it seats 4 people, it's got 2 doors, right? So we do the same thing with matter. We can classify matter according to its physical state. And the 3 physical states are solid, liquid, and gas. We are familiar with water in all 3 of these states. When it's a solid, we call it ice. When it's a liquid, we call it water. And when it's in the gas state, we call it steam. It's all water, though. And the difference in these 3 different states has to do with how the individual molecules are arranged. In a solid, the molecules are close together, and they are in fixed positions. They're going to be vibrating, but they can't slide around, and that's why a solid object retains its shape. In a liquid, the particles are still quite close together, but now they're able to move and slide relative to each other. So a liquid will take on the shape of its container, unlike a solid. In a gas, there's a lot more space between the molecules. The molecules are not attached to each other in any way, and they can actually expand to fill the entire container. So not only does their shape change, but the volume changes as well. So here's more words to describe those things. In the solid state, we've got atoms or molecules close together in fixed position. They may vibrate or oscillate, but they don't move around relative to each other. So I like to talk about the 3 physical states of students. Right now, you guys are in the solid state. You're close together. You're not shifting around relative to each other, but you're not absolutely still either. At the very least, you're breathing and snoring, right? Some of you are just fidgeting, trying to stay awake because this is so exciting. You're taking notes, you're looking around, right? Solids have fixed volume and a rigid shape. The shape stays the same, and the volume stays the same because the particles can't move relative to each other. We can categorize or subcategorize solids into crystalline solids and amorphous solids. The word amorphous means without shape. Morph has to do with shape, and a is a prefix that means without. A crystalline solid has a regular repeating order to the particles in it. So you guys would probably be basically a crystalline solid right now because you're sitting in rows. An amorphous solid has no long-term pattern. So this might be kindergartners sitting on the rug around their teacher listening to a story. They're sitting, wiggling, not moving relative to each other, but there's not really any order. They're just kind of jumbled up sitting on the floor. In the liquid, the particles are still close together, but now they're free to move around. So this is what happens when we go up to chemistry lab. We're still in close quarters. We're close to each other. But now you're going to be walking around the room. So even though you're in this contained space, you're moving. So liquids still have fixed volumes, but their shapes will change. In a gas, the particles are more widely separated. This is like when class is over and you guys head out the door and you disperse, you spread out. You just spread out all over Fresno County or maybe even farther. No interaction between the particles. Because of this space, a gas will expand to fill its container. Liquids and solids don't do that. But gases are also compressible. If you have a piston like this with a liquid in it or a solid, the particles are already touchingly close. And so if you press down on this plunger, you can't squish them any closer together. They're already touching. They are not compressible. In a gas, there's a lot of empty space. When we're looking at a picture like this with these being individual atoms, there's no air in there. That's literally empty space. You can take air and compress it together because there's a lot of empty space between the particles. So this summarizes the properties of the three states. And a possible test question, which state of matter has fixed volume and variable shape? A liquid. Okay? And so you should know the things in this table.